Hello all, thank you for joining the Creo Simulate Live for Industrial Design webinar. Some topics that we'll cover today include what is Creo Simulate Live, what are the benefits of using CSL, and we'll also take a look at some topology optimization. My name is Bill and I've been at PDSVISION for 3 years and my focus is in industrial design. That's a picture of my son and I right there at Walt Disney World. So what is Creo Simulate Live? CSL integrates real-time simulation into your design process to accelerate development and enhance the reliability of your products. It allows you to simulate how your products would behave or react to forces in the real world. So from my perspective, as an industrial, as somebody that's working in the concept development phase and ID, I need to focus on, how to improve my products, but I'm not a simulation expert. So I'm trying to apply, forces and constraints and stresses to the model or the product to, find pain points and allowing me to modify the product to improve it, to optimize it and make it better. So that's how I'm using it. I'm thinking about more in the concept development stage, and this webinar is kind of coming from that angle. Oops, wrong direction there, forgive me. What are the benefits of CSL? Provides designers with quick results. You can easily make changes to your model and CSL updates in real time. You don't have to be a simulation expert to use a software, and only takes 1 to 3% of the time it would typically take with something like ANSYS. So again, there's a couple times here where we emphasize speed, and that's important. This tool is meant to give you quick, fast data, right? So, instead of waiting 1 day or 2 days for the results that you need to make changes to your model, at this stage, at the early design stage or the concept development stage, you're more interested in doing some quick tests to kind of gain a better understanding if what you're trying to do works, if it doesn't, if you're kind of on the right path. Are there minor changes that you have to make? Are there major changes that you have to make? This CSL tool is so fast that it really gives you the data that you need. It gives you the information that you need in the early stages, to make some changes to your model that will help, speed along the overall process of developing your product. We'll also take a look at topology optimization. So topology optimization helps you generate the most optimal geometry to meet your design goals relative to maintaining the structural integrity. So in this case, we see that we have 2 images. The one to the left is the original component, and the one to the right is the results after running the topology optimization study. So basically, in this case, I believe I said, hey, I want to reduce the mass by 30%. So I want to keep 70% of the mass, and I applied a force to it. And I also said, hey, you know what? I also want to make this manufacturable. So I want to optimize this also for a milling process. So I use what's called a linear extrude, and this is the result that I got. Now, of course, you can see towards the upper pocket of that part, we have a lot of negative gray space there, and then we have a little green extrusion that's kind of popping up, but it's not connecting to the rest of the geometry. In that case, I would probably want to make sure that extrudes until it hits that next surface and kind of closes that gap. So one thing to think about is that, these are concept development tools. We shouldn't see everything that they do as perfect. We should be using them as studies to optimize our parts. So in this case, the geometry that we see on the right wouldn't be the final geometry that is produced. It's just a way to visualize, this, or this is an option that you could go with, potentially something similar to this. But I would probably go back into this and just use this as a reference for designing a new part or something. So that's important to note, is that, what it generates is not meant to be the final part. It's just supposed to give you an idea of what that final part could be. All right, so with that being said, let's move to our first CSL study. Okay, so let's take a look at this fluid simulation study. So what we see here is an aircraft I designed, and this was sculpted in a tool called Creo Freestyle. So if any of you guys have seen that before, you know it's very powerful. You can basically sculpt like you would with clay, where you can push and pull. So it's a subdivision modeling tool. Um, so what I want to do now is I'm in the early design, that concept development stage, and I want to see how this reacts to this flow simulation or this fluid simulation study. So the first thing that I need to do was define the envelope or the enclosure volume. So I can quickly, come in here, go to enclosure volume and define that either by dragging these handles or entering in a value. So I've already done that process, and I've also added air, right? So what is the material that's going to be flowing over top of this thing, this airplane? Of course, it's air. And there's some other boundary conditions I had to define as well. So for example, we have flow velocity, and you can see that I've defined the magnitude, which is 880 feet per second, right? And I also had to define the direction. So what direction is this going in? And you can see that I use my coordinate system, and we're going in the negative z direction. So I had to enter in a value of -1 for that. Okay. I also had to specify the outlet pressure right here, and I selected that back surface as the outlet surface, and also temperature. So now what's nice is, and again, this is a fluid simulation study. If you go to the study group in the top left and expand the menu, you can see that we also have, or I'm sorry, the add simulation menu. We have structural simulation study, which we'll take a look at as well today. There's a thermal simulation study option, modal, and right now we're in fluid. Okay. There are some other options that you can change. So there's performance options. So if you want to define whether or not you want to focus on speed as opposed to the accuracy, you can adjust that slider there. So you can quickly move it over to the right or to the left. So I'm focused more on speed right now, because the accuracy, most of that stuff, I'll let the engineers focus on that. For me right now, I just need a general idea of how the forces are behaving here. Okay, so I'll close that out. And there's also transient mode. I'm not going to get too far into this, but basically with transient mode turned on, you get to create studies that take into account time, or what happens to these forces and how do they affect your model over a certain period of time. Okay. All right, so let's get right into it. So we've set up the envelope, and now I'm going to go into the simulate portion of this and click on simulate. And you can see that to the right, there's a legend that pops up. So right now we're looking at velocity in feet per second. And if we zoom in here, you can see that we have this cut plane, and it's also specified up here in the dashboard. I'm going to change my selection filter to fluid objects and then select that plane. And what this allows me to do is drag this cut plane along the length of the plane to see where there's areas of high velocity and low velocity, right? So we can see the areas of high velocity that are in red, and we have the areas in low velocity that are in blue. Okay. Now what's nice is that we can also take a look at some other things here. So we have pressure, right? We know that for an airplane, primarily, we want low pressure over the top of the plane and the wings, and higher pressure that's below the plane. And this is all about lift, right? We want to make sure that we have adequate lift for this plane. So I'm going to go ahead and rotate this as well. You can do that, but I'm going to switch back to velocity, and we're going to use streamlines now. So right now we're just using this cut plane cross section to kind of take a look at what's going on at that specific slice of the model. But now we'll click streamlines, and that gives us a different visual of what's going on. So you can see that this gives us streamlines, and we see the areas of higher velocity and lower velocity, and each one of these streamlines is colored to represent those that difference in speed. Okay. Now I can also expand the streamlines menu and choose streamlines option. So the options allow me to modify the streamlines themselves. So for example, if I wanted less streamlines, I can decrease the count. So I can take the bar and slide it to the left here like that. So I've decreased the count of the streamlines. I can also increase the width of the streamlines or decrease the width. So you have great control over display of these streamlines here. All right. And we can go in our different views. I can also select the inlet here, right? So I can change the size. So say for example that I wasn't concerned with seeing streamlines over the whole plane, just the middle portion. I can drag these in or drag them back out as far as I want. There's also particles. I can turn those on as well, and same thing. In the animation options window, I can select the particles button, and I can adjust the min gate, the max gate, and kind of bring that down a bit. This makes it a little bit easier to see what's going on here. Right, then we also have the vectors. So I'll turn off the particles. You can also show all three at once, the streamlines, the particles, and the vectors. But for the sake of the webinar here, I think it's easiest to see if we just do one at a time. So these are the vectors, and I'm going to decrease the width maybe for this one and show what that looks like. Decrease the count a little bit, and then increase the width some as well. Okay. So one thing you could also do is you can take this bar here and drag it down. So if you're only concerned about what's happening at a certain point in the simulation, like let's say right above 7,000, you can actually drag that down, right? So now let's take a look at another simulation study. So let's go ahead and deselect the simulate button here, and I'm going to switch to a different window here. Okay, so this is the airplane. I've also spent some time developing the landing gear, so I also want to test the landing gear assembly as well and see how that's performing. So let me go in here, let me extend this landing gear out a little bit before we get started. Okay, and go right to live simulation. All right, so you can see that right now it's showing the simulation objects. So it's showing my constraints that I have here on different parts of the assembly. I can actually click this button at the top, the simulation objects, and deselect that to remove that from the window. Okay. I'm also going to hide the airplane itself and just leave the landing gear so it's easier to see what's going on. So right now, we are looking at a structural simulation study. So we looked at a fluid simulation study previously, so now we're in structural. And you can see that I have a couple studies here. The first one is the one that's active, and we know that because we have the green diamond there. And I have some constraints set up as well. So I have a constraint here, constraint there. So I'm thinking about, hey, where would this be constrained on the plane, and defining that first, right? And then I'm also looking at the forces, right? So in this case, I'm adding a force. I can increase the magnitude here so that I have more force, and also these units. Okay, and then now what I can do is I can click on simulate again. Okay, great. So now we can see that we're showing this von Mises stress. All right. And if we rotate the model, it's going to show us the areas of, you know, high stress and low stress. There's also what's called this toggle for min and maximum stress. So if I select that, it'll actually create a circle at the points where I have the most stress and also the least stress. So the most stress would be the red circle and the least would be the blue circle. Okay. Now I can also animate deformation of the assembly. So if I want to see where there's a lot of movement, where it's deforming the most, I can come in here and take a look at that as well. And again, I'm just getting a color visual for this, but I can also do an animation so that we can physically see that deformation here. So let's click on animate deformation. Let's take a look at that. So that's pretty cool, right? I mean, this gives us a visual of there was a force applied, there were constraints added to the assembly, and now it's giving us a visual of, you know, where most of that movement would take place. Now, one thing to mention though is that this is highly exaggerated, okay? So in actuality, you know, I'm in inches right now. Let's say I change this to 1 inch, for example, right? You can see that I'm pretty much in the clear, right? So there's nothing really relative to the forces that I apply that would cause this thing to deform much in any way that would cause any problems for me, right? It's just that this specific tool, Creo Simulate Live, is, you know, it's exaggerating that for me so that I have a visual on what areas are good, like what are the best areas, and which areas are the worst. All right, and that's not to say that in other scenarios this would be more valid and that there really would be a problem relative to the forces that you applied. It's just that in this specific scenario with the forces that I applied, you know, it's exaggerating it, but in actuality, it really isn't that big of a problem. Okay, so let's go back to the stress here. What I love about CSL is that I can go in here, right, and, you know, I can probe this and I can find the area, right, that has, you know, the most stress, for example, find it and say, hey, you know what, maybe I can't completely in this scenario get rid of that stress. Maybe I have to modify that, you know, geometry a ton to change that or change some other things. But, you know, what if I wanted to see, you know, what a simple change would make to that? So this is the current stress right now, but what if I just go into that part, you know, select it, and then modify like this offset to match the other side? You can see that we have a discrepancies here. We have 1, we have 5 for the offset on that side. So I'll change that to 5 to match, regenerate. So it went from 1318 in that stress area to now 863. So it did minimize the stress in that area. But notice also that the max stress shifted from up here in this corner to that bottom corner. Performance options, same thing as before. Just want to show you that you could adjust the speed and the accuracy there as well. Here's a look at the fixed constraint that I've set. So basically to, you know, create that fixed constraint, you're going to select the surfaces of the model that you want to fix. Here's another one right here as well. So I basically said, hey, I don't want that cylinder to move. You know, that would have a fastener in it, of course, to hold that there. So let's fix that surface. All right. There's also another study here. So this was applying a force on the landing gear in that vertical Y direction. I also have a study set up to simulate what would happen if forces were applied to the door itself. And hopefully this doesn't crash here. I think we got lucky. Okay, cool. So in this case, I have some of the same fixed constraints, but I have my loads different. So I've applied a force to this door to kind of simulate, I'm thinking about certain wind gusts and things like that, and how it would handle those things. And again, I can go back in here now, and I can go to my stresses and look at that. It shows in this area, and I can also take a look at deformation and then simulate that. So I'll just go in this view right here and animate that. So this information that I'm getting is really good. It's basically saying, hey, in theory, these areas where we're seeing most of the movement are areas that you have to think about, because this is going to be where it deforms the most. So you may have to reinforce some of these areas, add more strength or whatever, or think about another design approach that would minimize some of that. Okay, great. All right, so you can see how easy and how quickly we can get these results. I want to emphasize that, right? Typically, if we're using ANSYS software, we want to get as accurate as possible, right? That's the goal, especially when you're dealing with, in this scenario, I'm using this aircraft, this landing gear concept as an example. Let's just say it was, one of the commercial airlines or something, right? I mean, you really have to rely on really accurate real world data. I mean, the simulations you do in ANSYS, have to be spot on. For this, we're not really concerned with that, right? We're just using this we're using these simulations in CSL to gain information in this concept development stage to improve this, to get it to a point maybe to where we then can hand it off to an engineer and let them kind of take it from there, right? Okay, so now let's also take a look at topology optimization. So there's a hinge right here, and basically what I want to do is I want to let generative topology optimization run an analysis on this and reduce the mass of this component by a certain percentage while still maintaining its strength. So let's go ahead and open that component up. Okay, so here's the hinge, pretty simple part. And you can see that I've created these bodies, and there's a reason for that. So before you start your topology optimization, you need to use bodies to define certain areas of the part that topology optimization will take into account when it does its study. So for example, body one would be the starting geometry. So this is the geometry to start with. Take it away and optimize this geometry and recreate the geometry from this in a way that will reduce the mass, right? And then I also have body 2, 3, and 4, and all those bodies are bodies that I'm telling the optimization study to preserve. So these bodies right here, do not change them, keep them as is, right? And then I have this other body, which is a thickened surface body that I'm going to use to apply a force to, okay? So to find the generative design topology optimization, you have to go to the applications tab, and it's right here, okay? And then once I'm here, I have to define my starting geometry. So I'll select starting geometry, and I'll say, hey, this part right here is a starting geometry. And I'll also define my preserved geometry, which is this body, these bodies, and that center body right here. Then also I need to apply a contact between this body and the starting geometry. And then what I can do is I can apply a force. So I'll grab my loads, I'll select that surface, and I'm going to go in the negative Z direction to match, because if you look at my coordinate system, the left direction is the positive Z and the right is the negative. So I'll do a negative 1, and I'll just enter in a value here for that. And there's also generative design options. And what's cool about this is you can define how many cores to use. So my computer, for example, has a total of 16 cores. So what I can do is I can say, hey, you know what, use 14 cores to run this study, but leave 2 open for other things that my computer needs access to in the background, or other, processes running in the background. Click OK. There's also this design criteria, and this is great. So here's where I can basically tell the study and say, hey, you know what, I want to preserve 75% of the geometry here. And I also want to add a constraint. So let's add a linear extrude constraint. And basically what this will allow me to do is it'll create geometry that's manufacturable, that can be milled out. All right. And I also have the material here, which is steel. This could be aluminum, like a high strength aluminum as well. Click apply and OK. Okay, so that's defined. So what I'm going to do now so that we can see the optimization is I'm going to hide the 5th body here, and then I'll run the study. See what's not defined yet. Structure, delete that one. Constraints, oh, constraints, so we forgot that. So let's add the constraints in. And I'll constrain it here where the fasteners would be. Okay, great. So now we're ready to go. I'll click the optimize button. So right now we're at 13%. And we're about 35 seconds in. And again, just a reminder, the more cores you use, the faster this should go. So my previous PC had about 6 total cores, so I only had like 4 to use. So it took a lot longer than this one is taking now. We're about 1 minute in. It's fascinating to watch this product work and see it creating this really futuristic style geometry. It's kind of cool too, because it not only reduces the mass and keeps the strength, but it kind of gives you a futuristic kind of look too. So there's a lot of people in the industry that use similar tools to this to create geometry that has that futuristic style to it. So we're at 80%, about 2 minutes in. Now, it's important to note, like I mentioned before, that this geometry that it creates isn't meant to be the final geometry. I'm sure a lot of you guys, after this is completed, or even now, would say, hey, I see some flaws in that already. It's disconnected here. If you were to apply a force from the opposite direction coming in from the side or something, so it can only, it can't take into account multiple directions of force. But I think in theory you can do this and then do another study and apply a force from the opposite direction. But at least this gives you a visual on what this product does. Okay, so I'm hoping that you enjoyed the webinar and got a good taste of how you may use CSL to your benefit, as well as topology optimization. If you have any questions, please ask them. Again, I'm not a simulation expert. I just use this tool in the way that I would use it in the early concept development stages. But if you have any questions, if there's anything I can't answer, that stuff should be documented, on a spreadsheet somewhere that we can take a look at, and I can talk to the simulation experts at PDSVISION and answer your questions. Okay, so I don't see any questions coming in. If you guys do have a question, feel free to email our sales team. You can also contact me directly. So I'm sure there's some people that were on the webinar that know me, feel free to ask me anything that you want and I can get you an answer. Thanks a lot for joining. Thank you.